Hey guys, in this episode of Shri series, we're gonna be doing more questions on stoichiometry. Alright? If you looked at my previous video, we had a similar question with this where we had to write down a balanced equation, use the concept of moles, molarity, and volume, mole ratio, and then also use the relationship between mass, moles, as well as relative atomic or relative molecular mass. All right. So I'm going to read this question out, and I'm going to show you a step-by-step process on how to work through this problem. Okay. So I'll read it out here. Determine the mass of silver chloride that can be precipitated when excess silver nitrate solution is added to 719 ml of 2.28 mole per liter potassium chloride solution. All right. So what information do we have here? We've got the volume and we've got the molarity of potassium chloride. And as you see from the previous video that I put up on stoichiometry, the question was exactly like this. All right. You were not given a chemical equation. You need to identify what are my reactants, what are my products. Now, if you look at the information here, you can say the mass of silver chloride that can be precipitated. So we know very well that this is a precipitation reaction. All right. What are my reactants? It says when excess silver nitrate is added to potassium chloride solution. So we need to write down this equation. Silver nitrates, AgNO3. That's an aqueous because you know very well all nitrates are soluble. Reacting with potassium chloride, KCl, that's aqueous. And you're going to get silver chloride, that's a solid because that's precipitated, and potassium nitrate, which is aqueous. All right. So if you look at this question here, we need to ask ourselves, are the correct state symbols used? Yes, we have. We've got the precipitate, which is a solid silver chloride. Is my equation balanced? All right. So you can see silver there. NO3 is balanced. K is balanced. Chlorine is balanced. So in this equation, we're lucky that we don't need to balance this. And I'll explain to you why this will be an advantage, especially with mole ratios. All right. Now, let's look at the information. We've got a volume of 719 mils and we've got our concentration of 2.28. We now need to find the moles of potassium chloride. So we can say NKCl. All right. So N means number of moles of potassium chloride, and the formula is molarity times volume. All right. Now, some textbooks use C in place of M to say concentration because molarity is concentration because that's the number of moles per given unit volume. All right. So we've got 719 divided by 1,000 because remember it's in milliliters. We need to convert that to liters and we multiply that by 2.28 moles per liter. All right. So I get my calculator, 0.719 multiplied by 2.28, and that's going to be 1.64 moles. So the number of moles of KCl is going to be 1.64 moles. Now, we need to get the mass of silver chloride. Now, if you know very well here, so what I can do is I'll just put a small m, use different color, to tell you what mass I need to do. We know very well that we need to get the number of moles of silver chloride, and this is where we use the mole ratio. All right. Now you can see here we can already connect from this situation. We've got 1 mole KCl to produce 1 mole AgCl. All right, so let me just zoom this a little bit. There you go. So we got 1 mole. Sorry, we got 1 mole KCl to produce 1 mole AgCl. All right, so you can see it's a 1-to-1 ratio. So if you look at what's 1.64, that becomes easy because automatically we now got 1.64 moles of AgCl. I always tell students that when you've got an equation where you don't need to balance, it's already done for you, especially when it's a 1-to-1 mole ratio. That's even easy because then you don't need to do this basic arithmetic question or mole ratio concept that I showed in the previous video. Because you can see here we've got 1 mole of KCl that produces 1 mole of silver chloride precipitate. So therefore 1.64 will produce 1.64 moles of AgCl. All right. The next thing we need to do is to get your mass of silver chloride, which is number of moles times relative molecular mass, all right, because silver chloride has silver and chlorine. What's my moles here? 1.64, and I need to get the relative molecular mass of silver chloride, which in this case is 143.35, and we multiply these two, and you're going to get 235 grams of AgCl. So that becomes your mass of AgCl. All right, so you can see, like I said in the previous video, you need to know your chemical equations. You need to know what happens in a precipitate reaction. You need to know the state symbols and you need to balance it. It all comes back to knowing your valencies as well. You need to know the formula that links moles, molarity, and volume. You need to know your mole ratio. And lastly, the formula that links mass, moles, and relative molecular mass. All right? Thanks for listening, guys. Bye now.